goes. All right, so it's a difference quotient. So I have to compute f of x plus h minus f of x over h. So let's go ahead and do, why don't we do 1b? So this is gonna be x plus h squared plus 1. So I'm using this piece. But instead of using the x, I'm going to use x plus h. And then it's going to be minus, so we just did this. Now I'm going to do minus f of x. F of x is just x squared plus 1. And it's over h. All right, so then let me go ahead and take this piece and multiply it out. So this is x squared plus 2hx. I'm doing the FOIL method. So you know that may take you a little while to figure out what exactly I did. And then now I'm just distributing that minus sign. And then the nice thing is that this guy and this guy cancels. And I missed something. I missed this plus, whoops. Let's undo that. I missed this plus 1. So I should squeeze it in here. Okay, but that plus 1 and this minus 1 cancel. So then I'm left with 2hx plus h squared. So all that's left is this guy here, this guy here, and then of course the denominator over h. I'm going to factor out an h. And that leaves me with 2x plus h, because these cancel. And that's how you do this problem. Okay, so here's the next one. It says let g of x be x minus 5 times x minus 23 squared minus 23 minus 20. So sorry, the coordinates stuck here. All right, so it says give the coordinates of the vertex. That's about as easy as things get because it's x minus h. The general form is this plus k. So basically for a, it's 23 comma minus 20. I mean, you can rewrite this as plus negative, and then you could see the h and the k is your vertex. So this is just find the h comma k. Okay. And then it says explain how g of x is transformed from y equal x squared. So that's the parent function, right? So the parent function is this one. So there's a couple of things. Actually, there's 3 things going on. So let's do them one at a time. So one thing is that it's shifted right 23. So there's a shift to the right 23 units. Okay, and then the minus 20 is the next thing we'll do. So that's a 20. That's a shift down of 20 units. And then the 5 it multiplies the outputs by a factor of 5. Multiply outputs by a factor of 5. Okay. So those are that's part B. So that's what those 3 numbers do. Okay, and then part C says, what are the zeros of G of X? The fastest way to do that, I would say the fastest way to do that is to, the best way that comes to me is to take this and multiply it out, right? So you've got 5 times x squared. So FOIL it out. Minus 46x. I'm trying to think if there's a better way to find the zeros. I can't think of a faster way at this point. And because 23 squared, I've got to do that with a calculator. If I have my calculator, it's going to work out. So bear with me here. It's really just a matter of multiplying it out and maybe using the quadratic formula. I'm not sure we'll have time for that. I may just kind of guide you to where you use a quadratic formula, but I'll at least get you part of the way there. 23 squared is 529. And then it was a minus 20. We'll keep it that way. And I think, actually, I think an easier way just occurred to me. So yeah, this would have worked out. And then you could use the quadratic formula. But I just thought of a much easier way. Set the left side equal to 0. So yeah, when you're recording on the spot, sometimes you realize that there's a better way. So that's easy to solve, right? That equation. All I need to do is add 20. So I've got 20 equals 5 times x minus 23 squared. And since I need some room, I'll just delete this up here because that was the easy part. I'll just keep working up there. What I'm going to do is divide by 5. Yeah, this is a much better way. So I've got 4 is equal to x minus 23 squared. Take the square root of both sides. This is a plus or minus 2, right? Add 23. Add 23. So I know it's totally messy. So let me erase some stuff that I guess by now you can always rewind the video. So I've got I've got x equals 23 plus or minus 2. So I've got two solutions. Let me flip those. So it's x is 23 plus 2 is 25. And 23 minus 2 is 21. Okay, so those are my zeros. Yeah, better than using the quadratic formula. And that worked out. All right, so here's the next problem for us to do. It says the cost function for product is given by that quadratic, where n is the number of units produced and sold, and C of n is the cost in dollars. Okay, A, what is the domain? In the context of the application. So it's a parabola, so it goes further to the left, further to the right when you're thinking about it as a pure math problem. But in the context of this story problem, we'll use brackets 0, and even infinity is probably not the most sense. It doesn't make the most sense because you can't produce infinitely many items or units, but we'll just go from 0 to infinity. It's got to be positive. That's the main thing. In other words, whatever this parabola looks like, we're looking at the positive side only. That's the only side that makes sense. You can't produce negative stuff. All right. Is the function 1 to 1 for the domain in part A? For the domain in part A, so I'm fairly certain it is, but we should look at the graph. Let me come back to that one. Let me come back to that one because I think I need to figure out what I need to figure out what the graph looks like. So maybe we'll just graph it somewhere and be content with that. But part C, so we did part A. I think we could do part C kind of, relatively easy. So I'm gonna do n. I'm looking for the inverse. So I'm actually gonna call this a y for now. So let me go ahead and just erase that. It's just easier, I think, if we do that for now. So I'm just gonna write it as a y, and then it's n squared plus 12n plus 2100. And it gives you the hint of completing the square. So to complete the square, you take the 12, you divide by 2, and then you square it. So that's 12 divided by 2 is 6. 6 squared is 36. So what I'm going to do is I'm going to add 36, but of course I need to subtract 36. Okay, so then I'm going to work with that part because it's going to look a lot like the way we ended the last problem. This is going to be n plus 6 squared. That's what completing the square allows us to do. 2100 minus 36 is 2064. Somebody double check my math there. And then but I'm pretty sure it's right. So I'm going to subtract the 2064. I'm going to subtract the 2064. So y minus 2064 is equal to n plus 6 squared. Take the square root of both sides. It's a fairly long process, but you're totally capable of doing this. And then the last thing I'm gonna, well, I've got two more steps. So, oops. So, I'm gonna move these two opposite ends just because it's what I need to do. And now I'm gonna swap the Y and the N. That's the whole reason for doing that. Except N no longer means number of units because I'm doing the inverse. So, and then I'm gonna replace with the inverse. So I should be able to do, so that's my inverse equation. And I should be able to do part D, and I'm gonna squeeze it in up here. Because it says use the inverse function in part C to find how many units are produced and sold if the cost is 32.20. So I'm gonna plug in 32.20. Can everybody see what I'm doing? Okay, nice. All right. So I'm gonna plug it in on this side, right? So it's the square root of 32.20 minus 20.64, and I went a little farther because I need to take away the 6. That's an equal sign. 32.20 minus 20.64. 32.20 minus 20.64 is 11.56. So it's a square root of 11.56 minus 6. I don't know that that's a perfect square root, but let's find out. Let's see. 11.56. That doesn't sound to me like it's perfect square, but it is. It's actually 34, take away 6, and forgive the messiness. Let me try to at least separate things so you could make sense of where answers are. So 34 minus 6 is 28. That's how you do that one. All right, so this is number 12. It says let f of x be equal to 2x plus 6 and g of x be x minus 6 over 2. Find f of g of x. So you take so we need to find f of g of x. So you take f of x, which is 2x plus 6, and inside of it, you're going to plug in g, which is x minus 6 over 2. And using my fancy cancellation pen, I end up with x minus 6 plus 6, which is x. And then now I need to find g of f of x, which is, so it's g. And inside g, I plug in f. So notice that my 6s are going to cancel. And I'm left with 2x over 2. And that leaves me with x. And so the answer at the end is that yes, because f of g of x is equal to x, which is equal to g of f of X. So there's a rule. Can't remember if it's a rule or a theorem, but if f of g of x is x and g of f of x is x, then they are inverses of each other. So that's it for that one. That's all you have to do. All right, this is number 15. It says the profit for a product can be described by the function p of x equal to negative 0.4x squared plus 280x minus 24,000, where x is the number of units produced and sold, and p of x is the profit in dollars. To maximize profit, how many units must be produced and sold? If you're familiar with these enough, you'll notice that this is a quadratic that is concave down, so it kind of looks like this, meaning that the high point is going to be the vertex. And so in kind of a hidden way, what A is asking you to do is to find the x coordinate of the vertex. So the question is stated in that way, but you should know what it actually means is find the x coordinate of the vertex. And as you might imagine, when they say, what is the maximum possible profit? They're asking for the y coordinate of the vertex. And then they've got something else going on in part C, which we'll take a look at when we get there. So for part A, the formula you should know is that the formula for the vertex is opposite of B over 2A. That's the coordinate of the x coordinate of the vertex. So maybe somewhere on the side we should say A is negative 0.4, B is 280, and C, which we don't really need for this, is 24,000. All right, so then this is opposite of 280 over 2 times 0.4 with a minus sign. Don't forget the minus sign. And I'm going to grab my calculator, which you can't see what I'm doing, but I'm just going to compute that. So it's negative 280 divided by 2 times negative 0.4. And I am getting 350. So if this is a come on, if this is a graph up here, then this is 350. And now we just need, that's part A. Now I need to figure out how high the thing goes to answer part B. And that's just a matter of plugging in 350 into P, which is negative 0.4 350 squared plus 280 350 minus 24,000. And I guess if you have a calculator, you can put the formula into your equation editor and do it that way, or just do it in steps, which is what I'm going to do. So 350 squared. This is quite time consuming. So if you have a favorite shortcut, like using equation editor in your calculator, then do that. I know, I'm putting y'all to sleep already. 0.4 times 122,500. I'm just computing this step by step, and hopefully, as all humans are, I am prone to error, but hopefully I haven't made any serious errors. And so I'm getting 25,000. That's a 5 there. That looks more like a 5. Now part C. Part C, let's do part C in a way that it doesn't require us to do a lot of algebra. It says producing and selling how many units will result in a profit of at least 9,000. Okay, so let me load my calculator here. All right, so the way I'm gonna do this one is I'm gonna put in the equation. So I'm gonna go back and forth because I'll have to remember what it is, wherever that is. So it's negative 0.4 x squared negative 0.4 x squared, and then it's plus 280x plus 280x I keep clicking on the wrong thing. Minus 24,000. Minus 24,000. And then over here in the second slot, I'm going to put in the 9,000. So this is where I'm going to put 9,000. And then I just have to find out where these two things intersect, which is going to be a little tricky because I'm going to have to adjust my window quite a bit. Maybe zooming out is what works the fastest, but not necessarily. Sometimes you have to just work on the window on your own. Okay, well, at least we got something we can work with. I don't think I've gone high enough, so I'm going to change my max to well, and I'm processing stuff, so that's not something I can show you, right? What's going on in my little brain. But that's what I wanted to see. Are you seeing my graph? Okay, so I want to find out where the red and the blue cross. Okay, so I'm going to calculate the intersection. Where is it? I'm looking for my cursor. Okay, no, I'm going the wrong way. Looking for my cursor. My Y should be close to 9,000. There it is. There's my cursor. You have to put your cursor close to the intersection in order for the calculator to work. You see the 150? That's one of your answers. But there's two answers. There's two ways. There's two ways of getting 9,000, which is the tricky part, right? If you're in a test and you found one answer and you want to be done, but there's another answer, and it's about right there, right? So 550. Okay, thank you. I appreciate the mini applause there. Okay, I'm happy for that too. All right, so that's how you find that answer. All right, so this is number 19. Let's try some of these here. Let's go ahead and go with maybe B. So it says 4 plus log of X is 10. Take away 4. That's log of X is equal to 8. Remember that the base here, which we never write when it's a common log, is a 10. And then just rewrite this as an exponential. There you go. X is 10 to the 8th power. Can you all see that? Am I sharing that with you? Yeah. You can multiply it out if you want, or just leave it as 10 to the 8th power. All right, so let's do, how about D maybe? Let's do D. 300 is equal to 1200 times 2 to the negative 0.1x. All right, so the first thing to do is divide by 1200. And let me continue it up here. 300 divided by 1200 is a quarter. Is equal to 2 to the negative 0.1x. And then what I'm going to do is I'm going to take the natural log of both sides. So take the natural log, take the natural log. What that allows me to do is to bring this exponent out to the front. So I've got the natural log of a quarter is equal to negative 0.1x times the natural log of 2. Okay, so now divide both sides by the natural log of 2, and I might as well divide by the 0.1 too. And that's gonna cancel, and then those cancel. So I'm left with my X over here. And you don't have to work this out. You don't have to put this in the calculator unless you have loads of time at the end of a test. That's the answer. Let's do one more. Let's do G. So 2 times the natural log of X plus 7 is equal to the natural log of 4x plus 10. Let me move this. I think I need to do a couple of things. I think I need to move this 2 up. The tough part is like knowing what the steps are. Understanding the rules is fairly easy, but being able to see them at the right time, that's the hard part, right? So, and then I'm going to move this over to the left. Natural log of 4x. And then, so when you move it to the left, it becomes a minus. I'm going to subtract the 7 from both sides. So if I take away 7 and I take away 7 over here, I'm left with 3. So hopefully you saw how I did all those things. I can combine the 2 natural logs with division. And I think I need some space, so let me. I don't need this anymore. Just rewind the video. And what I'm gonna do, I have to remind you that the exponent, the base down there is an e. So it's e to the third power, base to the third power. And I can simplify this. This is x over 4. Multiplied by 4. And that's your answer right there. Okay. All right, this problem says, suppose 6,000 is invested for 2 years. There should only be one and is invested. For 2 years at 7.2% interest compounded quarterly. Write the equation that gives the future value of S. All right, so for part A, the formula is, and we're using S of T is the amount invested is 6,000. And it's 1 plus R over N. This is our R. So we have to write it as a decimal. N is 4 because this is quarterly to the NT. So that's our equation. You could go ahead and compute that, but it's not necessary. It's better in a way to leave it because then you don't have to worry about rounding error until the end. So using the model in A, find the future value of an investment in 5 years. So I'm going to use my calculator for that. So it's a good thing I opened it. So I just have to remember a couple of things because when I transfer the calculator, I need to remember 6,000, 7.2 and 4. 6,000, 7.2 and 4. So it's 6,000, 7.2, which is 0.072, and 4. And just make sure you put the 4 again here. And it's not using T's, it's using X's. And I'm just going to quit out of here. Let me remember what the problem was. Find the future value of the investment in 5 years. Okay, so I should be sharing my calculator with you. So probably the easiest way to do, maybe go to the table and just go to 5. I know that's really small on your screens, but it says 85, 72, 50. If you prefer to use a graph, you would do trace 5, enter. Okay, I don't have the best window because I remember I adjusted the window for a previous problem, but the answer is there. All right, so the next question is using the model, find the number of years it'll take the investment to triple. We could do this algebraically, but why don't we do it with a calculator? What's 3 times 6,000? It's 18,000, right? So let's just use a calculator. I'm gonna use a table and I'm gonna go to 18,000. So 16 years. You see it? It's 16. It doesn't happen during the 15th year. It happens sometime in the 16th year. Okay, and that's acceptable. You want to do it with a calculator, fine. Just say you did it with a calculator and explain how you did it. You don't have to do it algebraically. I'll accept it with a calculator. There's an algebraic way to do it, but it's going to take more time and more work. This is acceptable on a final exam. All right, so let's try 28. I always dread doing those because there's a lot of room for error on those, but let me give that a try.